Hi YouTube. I hope everyone's staying safe during this 2020 coronavirus pandemic. Rather than being bored and sitting on the couch eating bonbons for this quarantine, I decided to develop a piece of touchscreen technology for the students at UMaine. And here it is. You're looking at my final result. We have a Raspberry Pi 3B, which is controlling an interface to a touchscreen. We have a level shifter right here, and this is strictly to allow UART 0, or the serial port on the Pi, to talk to serial port 2 on this Arduino board. These two devices can have a conversation back and forth. They can exchange data, they can exchange commands. The Pi will always be the master. So when the Pi asks for data, the Arduino will send the information from things like this potentiometer, which is acting as a sensor. Over here, we have a power transistor. What this is doing is taking pulse width modulation from the Arduino board, and it's stepping up the power. So it's shifting the 12 volts out of this battery so that we have enough current available to drive the fan. Okay, so let's make this thing go. First thing I'm going to do is click on Apps. Here are the apps I've loaded. The app I'm going to show you next was written in Visual Studio. And I really like Visual Studio. It's got a huge amount of power. So I can put graphics in my application, text entry. I can use the onboard typewriter keyboard, keyboard that pops up. All of that comes with using Visual Studio. I'll start my app. We get the UMaine logo, splash screen, so we know our app is started. And here's our control. So we have our faster and slower buttons, which are going to control our fan. So let's turn our fan on. And what I'd like you to do is watch this gauge right over here. So as I click faster, you can see the gauge went up, and now I've got a readout. So I'm at 100 bits out of 255. So I'm running about 40% power on the fan, and I can go back down. And if you'll notice, there's some text right here. This is the conversation that's happening over this level shifter between the two boards. And then, so that demonstrates that I can talk from the Pi to the Arduino and modify the pulse width modulation over here. Let's make the conversation go the other way. So let's read the potentiometer and send the data back to the Pi for display on the screen. Let's see if I can do this. So if you'll notice this gauge, as I turn the potentiometer, you can see the pointer changes. And I have it on a fairly slow refresh rate. I could turn it up and it would be much more responsive. Okay. I'm going to post all of the code for making this go, and I'm also going to do a whole series of videos on what it took to get to this point. This took me about 2 months, and it was only because I didn't know what I didn't know. So hopefully after you watch the documentation series, you'll be able to do this really in an afternoon if you have all the parts. It was a great project, a wonderful learning experience, and I hope my students get a lot out of it. So thanks for watching, and more videos are coming.